In a previous video, we looked at compound interest using the finance solver on the GDC. This video will look at loans and annuities involving regular payments. So in terms of how this will adjust what we were doing with compound interest, this is no longer the case. And we'll have to think very carefully about the flow of cash in payments. Is it coming in or out of the person's account? So, other than that, nothing else changes. If we look at question 1, we've got a couple affording to make monthly repayments of $1,500 on a mortgage. The bank is offering a 30-year loan at 11% per annum compounding monthly, and we want to work out the maximum loan. So if we get our finance solver up, we can start entering the values. So N is for 30 years with monthly compound, so 360 payments in total. The percentage is 11%. The present value is the amount of the loan, and it should be positive here because it will be money that the couple is receiving into their account. The payments is money going out of their account, and so that's going to be negative $1,500. What we're doing with this loan is paying it off over 30 years by making those $1,500 a month payments, and that's the amortisation bit. The amortisation means the death of the loan, so we want it to reach 0 as a future value. And the payments per year are 12. And so if we go back up to present value and hit enter, that is the amount that we can take out as a loan. $157,509.52. So, if I take this amount and I halve it, then it's $78,754.76. That's half of the loan. What's tricky here is about whether this has to be positive or negative. So what's going on here is they've taken a loan which has come into them. So that's the money they have. They're paying $1,500 a month, so that's negative. But this future value is negative as well because that's money that they're going to have to pay back. And it's important that that is made negative. If it's positive, you get a nonsensical answer that's greater than 360. You then go up to N and you hit enter. Now what's really important here is that you always round this N value up because these payments and the compounding, the payment of the compounding interest occurs at the end of every month. So N is actually 289. And then you could convert that to years and months. So it takes a long time. But then once they get to that stage, okay, you'll see it doesn't take that long at all. That's 72 months, 6 years, to pay off the remaining half. So that was a loan. Let's look now at an annuity. And an annuity is something that's going to be a payment coming into the person's account over a regular period of time. So again, this is not 0. And we have Stephen, who begins working at 21 years old. At that time, he opens a superannuation fund that earns interest at 4% per annum, compounding monthly. Over the course of his working life, $700 a month is deposited into the fund. So, that is money he is receiving. The annuity starts at nothing. There's nothing in the fund. And he receives $700 a month. He's doing that for 44 years of his working life. He works at 21, retires at 65. So 44 times 12. End of that time, he is going to have $1,007,044. So part B says if he wishes to withdraw $5,000 each month after he retires, how old will he be when the money runs out? So 4% doesn't change. There's the amount that he doesn't have. We consider it sitting in the fund is not his money. He's going to receive $5,000 a month. That's positive. We solve for n, and that gives us 334, which must be rounded up to 335. So 5 months. So how old's he going to be? He's going to be 92. 65 plus 27.